Hello, everybody. I can't see anything, so I can't tell you where there's open seats or if there are any, but come on in, see if there is in the middle sections. Otherwise, since there's still people coming in, I'll wait a little bit longer to get going. Hello. All right. Everybody can hear me okay? Yay, okay, hi. My name is Rachel. I'm a developer advocate here at Datadog, and I'm gonna be the room host for this entire room all day today, so I get to tell you interesting things about our speakers. And first up today is Harel, who is a senior engineering manager at Datadog, and Maciej, who is a senior software engineer at Datadog. And they are here to talk to you about data observability and OpenLineage. If you've noticed, there's 2 mics here on each of the aisles. When they're done giving their talk, we're gonna open it up for Q&A. So yeah, if you have any questions, just write them down and we will take care of it. All right, let's get started.
All right, awesome, thank you. So I'm Harel, this is Maciej. On top of being at Datadog, we're also contributors and committers at OpenLineage, which you'll hear more about. So 9 a.m., good morning. Thank you for coming for one of the first talks at Dash. This is kind of exciting to get a lot of people standing for hearing about data observability and OpenLineage. But before we talk about anything, let's give some context on the problem. So let's say we work at Canoe, a travel booking company. And we have a homepage, users can look up flights, book hotels from, but suddenly the homepage looks like this. And users are complaining, hey, what's going on here? I'm getting these recommendations for weird hotels. I'm getting the bottomly rated hotels. How can that be? I didn't make a deployment, no one changed anything with the algorithm for the ranking. There were no changes made recently, so everything seems green, everything seems okay. What could be happening? To try to understand one of these failure scenarios that can cause this, let's take a look at the data ecosystem at Canoe and how teams are organized. So we have several organizations. There's like a user ranking integration team that is pulling data from actually different sources of data. Then there's a machine learning team that is building the ranking algorithm for the search results, and that's feeding into an app team that uses that to serve traffic. So it could be that in this case, something happened. There was a bug in the integration service, and for some reason, maybe the values are inversed on the source data of the ranking. But then what happens? That data gets fed into everything that consumes this data. So the machine learning model is now training on bad data, and it's serving actually the exact opposite rank results. The app team doesn't know about it, but they use it anyway. And now the search results are, instead of this, they look like this. Not great. So to talk about one of the ways in which we can solve this, let's introduce a concept for data lineage. So even before we introduce that concept, actually, the main reason why we bring up this concept is because teams don't really know their dependencies. These are implicit dependencies that happen on data. They don't happen like service contracts, API to API. These kind of travel in the system. So before I talk about data lineage, who here has heard of data lineage before? See some hands, it's pretty bright. Okay, great. So this slide is useful then. So data lineage is actually metadata about data pipelines. It is about where data is coming from, where it's going. Each service consumes data, or each job consumes data, and it also produces data. It is the metadata that gets attached to these jobs, the things that we observe as these jobs run. So let's take it back to Canoe. Now, if we had this central place where we tracked for each data set, who's reading it, who's writing it, and we had this end-to-end observability, then the engineers could very quickly see, oh, I know where this issue's from because I know that there's the app team getting data from the machine learning pipeline, and that's using the integrations team data, and we would have resolved the issue much faster, hopefully. And really, once we have good end-to-end data lineage, there's so many other things we could be doing. We could look at impact analysis. So I'm about to push a change. what is that change going to do to any downstream systems? We can think of compliance, right? Like, I've been in situations where legal teams are asking me, hey, where is this data going to? Where is it coming from? So definitely a lot of useful things. Well, this is a nice fantasy, but in reality, data ecosystems are very complex and very heterogeneous. And this is just part of the logos of things that your stack could have. So how do we solve a problem where we need to collect metadata and connectivity and relationships between services when we have all these different technologies that are all not even speaking the same language? So we need everyone to speak the same language. Let's start with that. That's an easy problem to solve, right? Like the way for things to integrate and adapt with each other. You think so, right? We can't figure it out for electricity, and that's been around for much longer. So you know how we solve these types of problems when people and systems are not talking the same language? We add a new language. But seriously, though, we add it, and it works. And it's actually really taken off. And to hear more details about it, I'll pass it on to Maciej.
Thanks. So, introducing OpenLineage, but before introducing what OpenLineage is and how it looks like, let's first think how we might actually gather and observe this data so that we can use it. And there are like 3 major ways that we can do this. First is, let's look at source code and maybe analyze the queries that we have there. So let's have some crawler, look at your Git repository, find something that looks like a SQL, have a SQL parser, get the data, and report them to some lineage metadata repository or backend. And this has some, nice properties. Like, it's probably pretty easy to gather all the data from the repository, pretty easy to integrate to Git, but also might have some problems, right? It might capture dead code, stuff that's not deployed. The reality might not match the code base, might not match the production. So maybe there's something else we should do. And for example, process query or activity logs, right? We have a system that, for example, produces some query history table. And we can write a system that reads those, processes them, and it comes from some real activity, right? Or maybe the system that processes the data leaves some, just logs stuff, right? The same way works for many cases, and in many cases this is still has some drawbacks, right? For example, the log or query format could change at any time and your integration might not capture it. Crawler-based stuff is a bit delayed. And another thing is that you might not actually see that something has started, but failed to process data or failed to finish, which is also important information. And the third way is actually to integrate directly with your data systems, right? Not only orchestration, but processing engines, data warehouses, and other databases that process your data. So as the jobs run, the integration directly can observe what happened and report it to your lineage backend. And that's what OpenLineage tries to do. So why is that the best? Like, we can look at the picture, right? And where it was taken and when. So we have the sunset, so it should be in the west, right? We might deduce something from the rocks, it's volcanic stuff. But photography, digital photography has solved this already. And we have something called EXIF in the photos. And this basically means that photo, like your phone or camera, uses GPS information and time to actually record exactly where the phone was taken. And this means you don't have to do all this manual work, guessing, and you can just use what was collected by the actual camera, right? And the same is true for all the data processing systems. We don't have to guess based by logs or by parsing our own queries. The database knows what data it processes, right? So OpenLineage thinks it's the best way how to collect lineage data. And, well, so OpenLineage is an open vendor-neutral standard, and it's designed to collect, share, unify the metadata about data pipelines and their lineage. So to help the organization understand how the data moves and transforms and gets consumed. So it's open source, and it's community-driven, defined as JSON schema specification. It also contains libraries for common languages, like Python and Java, to allow the contributors and anyone to basically write integration, and set of integrations owned by OpenLineage community to integrate with some of those mostly open source data tools. So why is important to have this open standard, right? And without the standard, there might be multiple lineage consumers, a lot of systems that try to collect, process this data, display it to you, but it introduces duplication of effort, right? Everyone has write their own dbt or Airflow or Spark integration. And each vendor tries to focus on one part of the solution, right? Let's say I'm writing a lineage system for ML-based data, or maybe for a specific database, right? And this means the operational value of this is low, because you can't seek the connection to the data quality issues at the left of the pipeline. And if schema changes there, you will just see the effect. You won't know why your dashboard have the wrong numbers. And if you are at this conference, you probably heard of the, standard that tries to do something very similar, but for general, let's say, observability, telemetry. And it might sound very familiar to you. Why? Let's look at OpenTelemetry mission, right? It's led by the Cloud Native Computing Foundation, which is part of Linux Foundation. It's a collection of tools, APIs, SDKs, and use it to instrument your systems to collect traces, metrics, logs for distributed software systems, and many people use it, many companies use it. So if we just change a bit data, we can see that OpenLineage shares a lot of the DNA, right? But instead of focusing on the telemetry data for those services, we focus specifically on lineage metadata for data pipelines, right? OpenLineage is part of LFNAI and Data Foundation, which is also part of Linux Foundation. We're also a collection of tools, SDKs, APIs, and we want to analyze our pipeline performance. So we borrow from the successful model of OpenTelemetry, but want to focus on the lineage. So let's actually talk what OpenLineage is about, right? And it has some core concepts. So there are jobs, runs, and data sets. And job is basically a pipeline task that transforms the data, right? It can be a Airflow task, maybe Spark job, maybe dbt model. It's identified by name and namespace in our world. And run is a specific execution of this job, identified by run ID. And if you think of batch systems, it maps very well to the understanding, right? You click run on the Airflow DAG, and you can see a few of the runs, right? And datasets, which is an abstract way of thinking of all data consumed or produced by pipeline. And we also identify it by name and namespace. So actually, those are the only core entities, properties of those entities. And so those are reasonably abstract things, right? It makes sense to decouple any other concerns. And why? Imagine if OpenTelemetry mandated including HTTP request version in the span specification, for example. If you wanted to use it for Kafka or gRPC, that wouldn't make any sense, right? So that's why we have a separate concept to attach all this additional metadata, and that are facets. So those are basically flexible metadata structures, whatever that means. We define this by JSON schema. It's like a dictionary in Python, map in Java. It can be anything, really, that you can serialize. So there are both standardized facets that you can touch, and those express the information that's common for many systems. Like, for example, for dataset, it's pretty often that you encounter dataset that has schema, right? Columns, fields that contains. Many jobs, for example, process information about process SQL, and we can attach the information, what SQL is executed. And for run, we can attach something like called parent run facet, and it allows us to categorize the jobs into some hierarchical information. So yeah, we get these facets, entities, but how do we transmit this information actually? So OpenLineage defines events that are configured that are basically defined to send particular information about runs, jobs, and data sets. There are 3 types of events, like we have run event, job event, and dataset event. The dataset and job are used to transmit more static information, right? But what's really interesting and allows us to do this lineage capture at runtime of the job is the run event. And it contains all of those entities, basically. Specifically, for the dataset, it contains separately input and output datasets. And input datasets are the data that it consumes, and output datasets are the datasets that it produces. So those run events have a life cycle, right? We want to use them to track the data at runtime. So like a single event emitted at the end of the job is not sufficient to transmit all this information. And we have like a standardized life cycle, right? When the job starts, it emits a start event and contains the data, right? And then we might have a long-running job or streaming job. And it makes sense to emit something that basically acts like a heartbeat, right? If you have a streaming job that would run weeks maybe, and you see a start event and then nothing for a long time, you might assume that, well, maybe check if it still runs, but OpenLineage can emit information about this as a running event, right? And then the job completes. Even those streaming jobs sometimes fail or you want to upgrade them. And for batch jobs, it's pretty obvious when they finish. And there are possible states, right? The job can complete successfully, then we emit the complete event. It can fail, or it can be like killed externally, and we have an abort event for that. So let's look at the example, right? It's an OpenLineage event, and we can see like event type, it completed. Yes, event time, when it happened. The run object, it has a parent run facet that I talked before, basically denotes what other run has spawned the event. Below we have a job, and this is, describes the name and namespace of what happened, and has documentation facet, which allows you to add some quick description to this. And then we have input datasets and output datasets, and in input we can see how schema facet looks like. It has a list of fields and types of those fields. And for output, in this case, we capture the statistics, right? So how many rows was processed and what's the size that was, in bytes that was processed, and some column stats, maybe. And so, we've talked about how this standard allows us to unify the lineage metadata, right? So let's look at actual realistic scenario where your team uses 2 different tools. You use Spark to transform raw data, and from like S3, and it puts it into Snowflake. And then you have like data analytics team that uses those structured tables and performs some analysis, fits maybe machine learning models, right? And OpenLineage allows us to connect those 2 distinct stages. So the lineage captured by Spark is fully compatible with the DP queries. And let's look at why. Well, because we standardize the dataset naming, right? So let's look at this in more detail. The part, when the Spark job produces the Snowflake dataset and understand it, is also a part of OpenLineage standard. And we prescribe the naming conventions for the different datasets, including like databases. So for Postgres, we capture the namespace host and the name of the table, which is like database schema table, right? Different databases might have different schemes. For warehouses, we do pretty much the same, but for example, BigQuery is pretty different because it has only project ID, dataset ID, and table ID. There's no like instance of BigQuery. We capture object storage paths, so the path to dataset. And we use this because the lineage is built on correlations. So there is no, if you think back about OpenTelemetry, where you have a single request, and you can propagate this context, right? Data world doesn't work like that. So you have a pipeline, you have one team that produces the data, it puts somewhere, and then it doesn't interact with it later, right? And you have another team that might read it. And we have to observe those specific jobs separately and use the naming convention to stitch the lineage graphs together, right? And this visualizes this concept more. So like services pass the traces ID in the request headers, and then all the event knows it's part of some trace, right? We don't have that. We don't embed any information into like data set rows that allows you to maybe know later produces them. And this has some real-world consequences. So let's like compare how this looks visually, right? So lineage is visualized maybe something like that, right? You can visualize how the jobs look on the time axis. But without something explicit, we won't be able to visualize why are they correlated at all. So we have both job and dataset entities visuals here. Sometimes we have more explicit versioning information for like iceberg or data, which are the modern table standards and contain this information, but sometimes not. And we have to do correlation. And for tracing, it's more explicit, right? Because the spans are part of the trace, and we can see the visualization on the map. And there are more similar concepts to OpenTelemetry, where we share like maybe similar concept problems and approach them differently, right? So like for distributed traces and data lineage, I've already showed this, but we have like a contract, right, between services and maybe jobs. And the service API is pretty similar to dataset schema. For like service level objectives, the same concepts are, there are also similar concepts, right? The availability of the service and like latency is a bit similar to like freshness and data quality works. And there are differences, of course, like tracing is heavily sampled, right? You don't want to sample your lineage data because you might miss very important connections. And so why would you use one or another? I think you don't have to choose. They both complement each other. And if you use like OpenTelemetry to ensure the health, performance of your systems and OpenLineage to track the lineage metadata, you might be able to achieve end-to-end visibility into your data ecosystem. And now I'll get back to Harel, who will tell you how we use OpenLineage at Datadog.
Thanks, Maciej. So cool, we're two engineers. I mean, I'm a manager, not an engineer. But we're two engineers, technically speaking, that work on OpenLineage, and we work at Datadog. It's a matter of time until we find a way to make an excuse to use this in the product, right? So let me show you a few cases where we made OpenLineage make our product work. And this will, I feel like this will also give you a bit more of a materialized example of like how easy it is to use it, but also, and actually not that easy, but how much rich metadata you can actually extract from it. So in this case, you're looking at our data jobs monitoring product, which is part of our data observability product suite, and you're looking at an Airflow DAG. You can see, kind of like top-level metadata extracted from the DAG runs, from the task runs, things like duration, things like task status or failure, pretty basic stuff. We can go in to a specific DAG. In this case, we have an Airflow DAG that is kicking off a DBT project. We can look at the timelines of execution. We can see when each task starts and ends. We can see within the DBT project, we can go in and see how long did the DBT project took to run and each of the different steps in the DBT project. And if you look very closely at the bottom, you can see this is all based directly on OpenLineage events getting ingested into the product. Getting an even closer look into the DBT model itself and inside the DBT project, we can look at things like, if you again look at the bottom here, you can see the inputs of this DBT model that I'm currently highlighting. And this DBT model has, I can't read this. This DBT model has some dataset ID, and you can look at all of the columns that are there. And this is fully captured at runtime by the OpenLineage wrapper that observes the DBT job as it runs. Pretty cool. But as Maciej also mentioned earlier, this doesn't work only for dbt jobs, it works for Spark jobs as well. And the interesting thing about this example is, and the work that actually Maciej did here, was being able to connect between a job that we're using the Datadog agent to observe a Spark job with and the Airflow DAG that is kicking it off, propagating the context between the Airflow DAG and the Spark job that is instrumented with the agent. There's also an OpenLineage instrumentation for Spark, but I wanted to highlight this case where we're combining and mixing and matching both in the product. The way that we do this is we use the OpenLineage run ID and the concept of OpenLineage called the parent run ID that allows us to connect between different entities and different jobs, and that allows us to build these cohesive product experiences. So here, I kind of scroll down to that area of the product where you can see the parent job ID in the metadata for the Spark job. So basically, when Spark kicks off the dbt job, it passes forward its run ID, propagates the context, and so on and so forth, and that can go on for a very long time, and then on the back end, we stitch everything together. Another cool and useful thing about OpenLineage that we do at Datadog is that it saves us a lot of engineering discussion and figuring out what should ingestion look like, right? What is the data model that we use? Oh, well, let's just use OpenLineage. If it doesn't work, we'll tweak or we'll extend, but the model is pretty extensible, and then it saves time on making these engineering trade-offs and decisions for the team internally. So in this example, we're actually using OpenLineage to observe BigQuery and Snowflake telemetry that we have a crawler that's connecting to these environments, taking data from things like information schema, query history, and so on, and shows freshness data, availability, data sizes, rate of change. This is all not necessarily instrumented at runtime by OpenLineage, but as Maciej showed earlier, the spec supports being able to be declarative about this information, not only when the job runs, but also after the fact. And finally, of course, it supports showing lineage in the product. This is where I'm going to hold off on showing anything more in the product because I definitely want you all to check out the keynote where you'll see more about this. And then also definitely check out our booths at the Expo Hall to hear about what we're using OpenLineage for. So to wrap it all up, how can OpenLineage benefit all of you? So for one, it powers what I think is a cool product. If you use it, it will benefit you. That's awesome. But also, it provides you with a unified observability across your entire data pipeline. When something breaks, it's much easier to pinpoint where it is broken. It helps increase trust in data accuracy and the provenance of data because you can trust and see, okay, this column is generated and calculated from these specific data source, which is easier to do. And it's an open standard, so the expectation of how it works are the same across the board in the industry. So thank you for coming to a 9 a.m. talk about open standards and OpenLineage. If you'd like to get involved, definitely check out our GitHub, join our Slack. We're pretty friendly on Slack, usually. We have socials. I don't know where they are anymore. And we have about 10 plus minutes for questions that we saved for. So again, thank you. Thanks, Maciej.
Thank you so much. All right, like I said when people were coming in, if you have any questions, there are 2 mics in the aisle. Just step on up and ask whatever it is that you are wanting to ask.
Yeah, please.
So there's data transition state changes. Is that an array of changes, or is that a single state?
So all the transition changes, it's an enum right now. There's all the stages that are there, but there's also an other stage, and I think, did we show running?
Yeah.
Okay, yeah.
And secondly, I don't know a ton about the project. I just started learning about it. Do you cover Kubernetes jobs? Will they be covered?
So Kubernetes jobs, we could represent them. It's a job. it runs.
Would I just treat them like a Spark job and use that job definition?
If
Yeah.
you have a Spark job inside, we can monitor that Spark using OpenLineage Spark integration.
Okay. 'Cause
However,
I do
like
want
generic,
the cluster identity to be represented in the lineage if I can.
So, I mean, you can shape the data into an OpenLineage shape, right? If we think about, let's go back to Maciej's example of like OpenLineage versus OpenTelemetry. OpenTelemetry is really at the single transaction, right? Like there's a single request and we trace it along everywhere. And OpenLineage deals with like a bit less granular representation. So if the representation that you're looking for in your job is less granular, then you could try to represent it with OpenLineage.
Yeah, I kind of picture the Kubernetes job being the parent of the Spark job, same way with it, kind of like analogous to Airflow.
Yeah. And one thing that we are working on is like propagating context between OpenTelemetry and OpenLineage within the product.
That would be amazing. Thank you.
Thank you.
I'm excited about this. Thank you for the share.
We are too. Thank you.
Hi, thank you. How have you handled schema changes? Was there any challenges in that?
Can you give a specific example so we can kind of...
Okay, so in terms of adopting OpenLineage outside of Datadog, we have identified where things are flowing, but schema mutates over time. So in this case, what the events are being produced, that changes, and then that would impact, I'm imagining, the traceability as such.
I would say that the integrations are focused on more like capturing the state right now. And then when we capture the events, the like backend can deal with it, right? Can detect that schema has changes before the last run and can actually alert you, for example. So I wouldn't say this is actually what OpenLineage integration maybe not give you this schema change directly, but it powers systems that can reliably detect this.
Okay, so would it be fair to say OpenLineage specification helps or defines how the data is captured at the runtimes? So we know what is flowing where and how to interpret it. That's a different problem.
Yeah, that's a decision that's delegated to the consumer of the OpenLineage event. If you want to check out something in open source, there's Marquez project. Marquez is actually it existed before OpenLineage. That's how the whole thing started. And Marquez captures OpenLineage events, and it stores them, and it stores the state. So you can kind of check out what it would look like to capture schema changes. It doesn't track like point-in-time lineage on a graph. That's a bit more complex than what Marquez can handle, but you can definitely see schema changes.
Okay. Thank you.
Thanks.
Hey. I'm curious if there's a relationship between like observing the actual data job runtime, like how it's executing, versus like the OpenLineage data. Like if you're observing one of your data jobs today and you're trying to see like if it, throwing errors or has any problems, like would there be a relationship between those two types of data?
What would instrument the first part? Like, is there, you mean there is a separate instrumentation that you use to monitor the data and you want to add OpenLineage to it?
Yeah, like if you're observing an Airflow task, for example, and you're trying to see if it's completing successfully and stuff like that, is that a different type of data than actually observing?
Metrics?
Yeah.
Yes, but actually both are part of Apache Airflow. So OpenLineage is like a native provider in Apache Airflow repo, and you can try them both. There is no like competition between those two. But they say like that joining of this data together is the job of a specific consumer.
Got it.
Also, like some of the metrics are kind of in OpenLineage events. So maybe one or another would be enough for you.
Okay, thank you.
And Maciej's being modest. He actually is a committer on Apache Airflow, and he contributed that integration.
Awesome. Thank you, guys.
I have a question. So how can we leverage OpenLineage for apps' better performance? Let's say alerts, triggers. So we are triggering all of that.
Sorry, can you just repeat? Leverage OpenLineage for what?
to track applications performance
Oh, okay.
and how we can make use of, in a best way, we can trigger the right alert and get to know more about how our application is performing, or do we really need the pipelines for that?
So for application performance, usually OpenTelemetry will do a better job probably at helping you capture that.
Okay.
So that's, Datadog's APM product
Right.
is a good example of that.
Yeah.
OpenTelemetry, of course.
So it didn't benefit that much.
Yeah, I mean, we can think of emitting aggregated metadata
Yeah.
about a job's performance and rolling it up. But usually you want to kind of track the performance of your application in real time, emit red metrics, look at traces, and that's a bit more granular than what OpenLineage gets into.
Pure OpenLineage can tell you that something is slow, but it won't tell you why, right? There is no
Okay.
like deeper insight into the code base or something like that. That's not what we focus on.
I see, because I saw one slide where it was, we can see where it starts, when it hits, what's the duration and all of that. So I was thinking probably we can capture those.
Yeah. This is available to see, right? There is no like deeper insight, as you
Okay.
can see with like Datadog's APM product, which will
Yeah.
actually tell you the life cycle of the single HTTP request
Okay,
and internal operations of this
got
system.
it. Okay, thank you.
Thank you.
Good morning. Thank you
Morning.
for the talk. Let's assume for the sake of argument that I'm an engineer just hired on at a company and I need a better understanding of where our data is and how it's being used. Is there a way to leverage OpenLineage to gain that understanding? Like what users are interacting with which data, or what parts of our system are interacting with which data, and how indeed those interact with each other? Or do we need to understand that in order to instrument this appropriately?
It's a yes and answer. So it depends on your data stack,
Yeah.
how easy it is going to be. Technically speaking, yes, this is exactly what this is for. But then the details matter, right? So are the data processing frameworks that you use support OpenLineage natively? If not, we'll need to build an integration that extracts the data and puts it in to OpenLineage format, and then you can use the product, for example.
Great. So the follow-up then is, you had mentioned the agent a number of times. Does OpenLineage currently support like cloud native, like Blue Jobs or associated things, or do we need a sidecar somewhere to say like, hey, there's a thing happening over here?
It's an excellent question. I actually gave a talk at reInvent last year with the Amazon Data Catalog PMs, and they've added OpenLineage support into Glue Jobs.
Dope.
And they use it internally at Amazon for like their data zone, or there's a different name for it. But yeah,
So harass our contacts
exactly.
at AWS. Got it.
Yes. And then talk to me, and I'll talk to them, and like figure it out.
Thank you so much, gentlemen.
And to mention another like partner of Dash, Google Cloud is also using OpenLineage in some of their products. So yeah.
We have time for probably 2 more questions so that everybody can make it to the keynote. So both of the people that are at the mics right now, that's going to be it for this session. But if you have any other questions, there's a booth on the expo floor, right? Okay.
Yeah, come to the data observability booth.
I have a question. So is this more like a vendor agnostic like OpenTelemetry, or is it only going to interact with the Datadog agents?
It is vendor agnostic. It's an open source standard.
Okay, so only difference between this one and the OpenTelemetry is that it's more, it's lesser granular? Is that the only difference?
Yeah, and it's built for data pipeline specifically, and all the data processing framework technologies, at least all the open source ones, are implementing it already.
Got it. Thank you so much.
Thanks for the presentation. You discussed at the beginning a hotel application and that the results were reversed or whatever. Can you walk through, if someone noticed that, how would they use OpenLineage to kind of understand that? Would they have to go talk to their team, or does the application itself show something? Or yeah.
So because there's less people, I can show more stuff on the lineage graph, but don't tell anyone I showed you, okay? Come to the keynote. But let's imagine, and this is not the right graph for this, but let's imagine the leftmost node here is maybe that kind of, I don't know, that reporting or some aggregate of the user data that you're seeing on like the top recommendations. And that's what you see the alert going off, right? And then you follow the lineage graph and you go upstream. So you hop over, okay, there's a Snowflake table. Oh, before that Snowflake table, there's a machine learning pipeline that's reading data from here, pushing data here. Before that, there's another and another and another. And obviously we do this in the product, but like if we talk about the spec purely, then it's just about, okay, we see the connections between each of those, but then you also need to go deeper and capture all the version changes, right? So like, okay, there's a snapshot now. This was the topology and all the metadata at this point in time. Go back a day when it was working, the topology and the metadata were different, and this is how you can observe these differences. Like think about the get SHA of the job, and maybe that's what you use to differentiate between the two. You wanted to add something?
I mean, if you look at the screenshots and the upstream issue part on the right, it actually does what it wants, right? It points you to the first upstream issue that happened, and you can solve that first one, and probably the rest will follow just fine.
But don't tell anyone you saw this.
Thank you.
All right, thank you. Thanks, everybody.
Thank you.